Okay, so these electron regions relate to how many bonds that central atom is making, obviously, right? Or how many lone pairs it has. There's something funny that goes on with this central atom. And what it is that it starts off with 1s2, 2s2, 2p2. And when it starts to bond, it rearranges itself to make bonds happen and to make bonds very equal and fair between all the different elements that are attached. And we've got some more videos that will show this digitally, which makes it make a little bit more sense. But these are the outermost electrons right here. And depending on how many bonds, like this wants 2 bonds right here, it's going to take some of this, the S electrons, remember those are the ones in the circle, and some of the P shape, and it's going to blend them. Kind of like when you have colors, and maybe you've got like a red color, and then you've got a yellow color, and when you put them on top of each other, it looks orange. That's kind of what it does. So when these two shapes come together, it's kind of like one side of this gets really big, so that part gets larger, and then that little tail part is really small comparatively. And so it ends up kind of looking kind of like that, because they're blending, and it's how they blend. And they always do like that. S only blends to like the one side of the P. It doesn't blend into the middle. It blends onto the one side of it. There's a reason for that. We don't have to understand it. So these regions match up with basically how many hybridized orbitals that the carbon wants to have. So when it makes 2 bonds, it has 2 SPs that are doing the bonding. When it has 3, it has 3 total sp2s that are doing the bonding. So in that case, it's got 2 of the P's and 1 of the S's, and they're all combining together. So you still kind of have that big lobe, but the end part of the lobe isn't quite as small, but it's still pretty small. It's a similar looking shape. And when you've got 4, you have a total of 4. That's 4 atoms. You have a total of 4 things, which is a total of 4 sp3s bonded. Now, like I said, there's a video coming up that's going to show this happening digitally. That might help it make sense. But you can also just know, hey, if you've got 2 regions, it's sp hybridized. If you've got 3 regions, it's sp3 too. If you've got 4, it's sp3. sp2, sp3. And then if you've got 5 regions, what's going to happen is a D is going to get involved. This is why only the 3rd row and below can do this kind of bonding, because they're the only ones that have Ds that are nearby that can do that. sp3D. And then finally, the last one is sp3D2. I also have like an easy shortcut way of remembering this. And you've got a total of 1, 2 letters in there, and that's region 2. This one has a total of 1, 2, and notice there's a 2 of the P's. So that has 3. This has 1, and it has 3 P's. 1, 2, 3, which is a total of 4 regions. This has 1, 2, 3, 4, 5. So you see in the trend. So if you count the total number of letters, it matches your numbers of regions. So we've got some more coming up. Again, that's going to show more of how this looks and what's going on. What we want you to know in the course is to be able to look at a molecule, and you're going to be able to say, oh, that's sp hybridized, or oh, that's sp2 hybridized. So you really just have to be able to match the shape with the name of the hybridization.